Hi everyone, welcome back to my channel. So good to have you here. If you haven't subscribed, please click on the subscribe button and also hit the bell sign so that at least you can get a notification if any video comes up. So for today we're looking at trigonometric identities and equations, and our focus is on verification of trig identities. So before we begin looking at any expressions on trigonometric identities, I'd like us to look at what we call the fundamental trigonometric identities, what's going to help us in resolving expressions of identities. So we have I have this table with me here. So there is this table I've presented. So these are the fundamental trigonometric identities that we're going to be working with in order to be able to resolve any kind of question that we have. So we have the top part here, what we call the reciprocal identities. I'm sure we all know what this is. So we have sine x is equal to 1 over cosec x, and 1 over cosec x is equal to sine x, and just like that. So all these should be in your head. You should be able to know all these fundamental identities, because if you don't know these, it will be very difficult for you to resolve expressions. So we have the ratio identities, the Pythagorean identities, and eventually the odd and even identities. So you should be able to work around these. So with the questions that we're going to be looking at, we need to have knowledge of this for us to be able to answer any kind of question. Then maybe on a comment on the Pythagorean identities. So with these identities, we can resolve them differently. So by virtue of us, let me pick the first one. We all know that sine squared x plus cos squared x is equal to 1. So from this identity, we can have two other identities derived from it. That is, in the first instance, we can make sine squared x the subject. Thus, we'll have sine squared x is equal to 1 minus cos squared x. So in this case, this is an identity we've made for sine squared x. Sine squared x is equal to 1 minus cos squared x. And also, we can have cos squared x as the subject. That will make us have cos squared x is equal to, we'll have 1 minus sine squared x. And this is also another identity we've derived from it. So as we work around identities, that should always be in your mind. You should at least try to work around what you've been given for you to achieve the given goal. So now, if we were to talk about maybe guidelines that should help us in verifying identities, I can only mention two things. One is that whenever we're given a question that you need to solve or resolve, one of the things that you should look for is which side is more complicated. Is it the left-hand side or the right-hand side? And you pick on the side that is complicated, trying to resolve it or reduce its complexity, so at least it looks like what you need. Then also keep the goal in mind. What you have on the left-hand side, try to match it to the right-hand side as you work out whichever side you've picked. As you work out, if let's say the right-hand side is more complicated than the left-hand side, try to, as you are resolving the side that you've picked, always keep the goal in mind of what you want to achieve. Let's look at some examples and see what we're talking about. Let's look at an example. So we're going to have this example where we'll be applying the concept of changing to sines and cosines to verify an identity. So our question is, verify sine x cot x sec x is equal to 1. So for us to solve this one, we first need to look at which side is more complicated. So we'll agree that the left-hand side is more complicated than the right-hand side. So we'll pick the left-hand side. So it's important to indicate which side you've selected. So if we pick the left-hand side, then we can write the expression. So now that we've written the expression, we need to resolve it. So this kind of expression, we can identify that it has the cot, the sec. So we just need to change them into sine and cosine because that's what we know and can work with. So let's do that. So that is, we're having sine x. So cot x is cos x over sine x, and then sec x is just 1 over cos. 1 over cos x. So from here we can identify what's common, so we can divide. So we have sine x can divide with sine x, cos x can divide with cos x. And we only have 1 left, which is everything is 1. So our final solution is 1, and this is equal to the right hand side. So we verified. So we can write hence verified or hence proved. And you're done. So for similar questions, whenever you have a question where you're having cot, sec, try to change them into sine and cos, and then try to see if you can divide and reduce it to what is needed on the identity. Let's look at this example. So we use a Pythagorean identity, and we're going to verify this expression. So when you look at these two, they all look to be of the same level of complexity. So you can pick either the left hand side or the right hand side. So let's pick the right hand side. So picking the right hand side, we're going to resolve it. So if you remember or recall the Pythagorean identity, we said it's this one, sine squared x plus cos squared x is equal to 1. So using this identity, we can resolve such an expression. So remember, I had made cos squared x as the subject. So when you make cos squared x a subject, we have 1 minus sine squared x. So we're going to have that replaced on cos squared x. So that is, we'll have 2. Then where there's cos squared x, we replace with 1 minus sine squared x. And then minus 1. So for any question that an identity you're given to resolve, where you meet either sine squared x or cos squared x, try to recall the Pythagorean identity and apply it to be easier for you. So we can expand. We'll have 2 minus 2 sine squared x minus 1. Then when we subtract 2 and 1, we'll be left with 1 minus 2 sine squared x, and this is equal to the left hand side. So we verified it. Okay, so in this next example, we'll look at identities that might require you to factor for you to verify them. So in this identity, we've been given this expression. We're told to verify it. So of course, when we look at it, the left hand side is complicated, so we'll go with it. So if you look at an expression like this one, we look at what's common. So sometimes you can have expressions where we're having something common and we can factorize it. So in this case, we can factor out cos x squared x. So when we factor it out, we'll be left with 1 minus cos squared x. So what could we do next here? So your knowledge on Pythagorean identity should come to apply when you reach this stage. This is a Pythagorean identity, and that is equal to its sine squared x. So we're having cos x squared, So we're having cos x squared x, and this is sine squared x. From here, we can change cos x squared x into 1 over sine squared x. It's an identity. So we change it. Remember the fundamental identities. So we'll have 1 over sine squared x multiplying with sine squared x. And here the 2 are common, so we can divide and we're left with 1. So this is equal to 1, which is equal to the right hand side. So we verified. So just as much as when you're given an expression of 4x squared plus x, there's a factor or you're told to work around it, your mind automatically tells you that you can factor out the x so that you have 4x plus 1. So in the same way when dealing with identities, look for an expression, look for ways that maybe if factorization is needed, or if you need to change cos to sine, you should apply such concepts for you to be able to solve the given questions. So our next example is an expression that demands you to use an aspect of multiplying with the conjugate. So this one usually applies on fractions where you have an expression of this sort. So it could either be 1 minus or 1 plus whatever you have. So in order to solve some expressions like that, you may need to multiply with a conjugate. So let's do that. So in this case, we'll pick, yes, the left hand side. So that is this expression. So getting to multiply this with a conjugate, so multiplying this with a conjugate, that is 1 minus cos x, 1 minus cos x, we multiply it with a conjugate. And when we multiply the numerator, we'll have sine x minus sine x cos x. Then below, since this is a conjugate, we'll just square and subtract them. So that is 1 minus cos squared x. And if you recall the Pythagorean identity, this part is equal to sine squared x. So if you look at the numerator, we can factor out sine x. So that is sine x will remain with 1 minus cos x. And then on the denominator, this is a Pythagorean identity, that is sine squared x. So we can have a division of sine x and sine x there. So that is, we'll have 1 minus cos x and over sine x. And this is equal to the right hand side. We verified it. So all the concepts we're looking at are coming into play as we solve. So one key thing I'll encourage you is that get to know the fundamental identities and then practice as many questions as you can for you to be fluent at solving them. Okay, the last example we have is we need to change to sines and cosines. So this one is this expression that we have sin x plus tan x over 1 plus cos x. We need to verify this identity is equal to tan x. So of course we'll begin with the left hand side because it's complicated. So picking the left hand side, we have that. And then resolving it, we're saying we need to change into sine and cosine. So here, you should not rush to say, let's say you try to use the concept of conjugate here, because we have this expression which is not in form of sine and cosine. So it needs to be changed as well. And then you simplify. So usually the times that we get to use the conjugate is when we have similar expressions. If we're dealing with sine and cosine, let that be the work throughout, then it will be easier for you to now apply the conjugate method. So write in our expression Then we change tan x is sine x over cos x. And this is dividing 1 plus cos x. So from here we can do the normal thing of having a common denominator on the numerator. So that is, we have sine x cos x plus sine x dividing cos x. So we have this expression again that we need to write here. So that is, I'll use a different marker. This whole thing is dividing 1 plus cos x. So on the numerator we can factor out sine x since it's common. So that is sine x, then we'll have cos x plus 1, then this whole thing is under cos x. Then we can rewrite this in a form that looks better by saying we're dividing this by 1 plus cos x. Yes. So from here, we multiply, then that will be 1 over 1 plus cos x. Then we can easily see what's identical here. We're having this, can divide. Remember, addition is commutative, so 1 plus cos x is the same as cos x plus 1. This leaves us with sine x over cos x, and this is equal to tan x, which is equal to the right hand side, and you're done. So with these examples that I've shown you, you're able to solve most of the questions on identities. You'll be able to find them easier. So just get to remember the concepts that you've looked at. Whenever an expression is presented to you, look at it. Do you need to change to sines or cosine? Do you need to factor out something? Is there a need to apply the conjugate method? So just try to work around any given question and you'll find that it will be easy for you to solve. Thank you very much for viewing this video. See you next time. Subscribe.